Students, we are going to see what is meant by mass transfer. Let's have a look on definition of mass transfer. It is a tendency to moving of species from higher concentration to lower concentration. This phenomena is called as mass transfer. We have an example here. This is a two compartments A and B. In this compartment A having higher concentration fluid, B is having lower concentration fluid. There is a tendency to move from higher concentration to lower concentration. This phenomena is called as mass transfer. Now, we will see some examples of mass transfer in our day-to-day life. Humidification of air in cooling tower, evaporation of petrol in carburetor in internal combustion engines. Next is transfer of water vapor into dry air and dissolution of sugar added to a cup of coffee. These are some examples of mass transfer. Next we are going to see the two modes of mass transfer. First is diffusion mass transfer. Second is convective mass transfer. This diffusion mass transfer is divided further into two types. First is called as molecular diffusion. Second is eddy diffusion. Now, let us see one by one. First, let us see what is meant by molecular diffusion. It is the transport of water on a microscopic level as a result of diffusion from a region of higher concentration to a lower concentration in a mixture of liquids or gases is known as molecular diffusion. Next is eddy diffusion. When one of the diffusion fluids is in turbulent motion, eddy diffusion takes place. Yes, mass transfer is more rapid by eddy diffusion than by this molecular diffusion. Next we are going to see the concept of concentrations. Concentration is important terminology we are going to use in this mass transfer. First let us see what is meant by mass concentration. This concentration is also known as mass density. It is given by the ratio of component mass by its unit volume. We have a formula, it is equal to component mass by unit volume. It is given by kilogram per cubic meter. Next we are going to see what is meant by molar concentration. It is also called as molar density. It is given by its number of molecules of a component per unit volume of a mixture. It is given by kilogram mole per cubic meter. We have a formula here. Next is we are going to see what is meant by mass fraction. It is defined as the concentration of mass of species to the total mass density of a mixture. We have an equation here. It is equal to concentration of mass of a species by its total mass density. This is called as mass fraction. Now, let us see what is meant by mole fraction. It is the ratio of mole concentration of a species to the total molar concentration. It is given by the formula. It is equal to mole concentration of a species to its total molar concentration. This is called as mole fraction. Next, we are going to see what is meant by Ficks law of diffusion. We have two partitions A and B. Partition separates two gases A and B. Here we have a compartment A and B. This is divided by this partition. Now, this partition is removed, the two gases diffuses through one another until the equilibrium is established. Ficks law states that its molar flux of an element per unit area is directly proportional to the concentration gradient. This is called Ficks law of diffusion. Here, MA by A is directly proportional to dCA by dx. We are going to replace this proportionality by this constant. It is equal to minus dAB, where this constant is given by diffusion coefficient of species A and B. It is in terms of meter square per second, where dCA by dx is equal to concentration gradient. This MA by A is also given by NA. This is called as Ficks law of diffusion.